Hi guys, welcome to Closer's Mathematics class. Don't forget to subscribe, like and share this video. Alright, today we'll be talking about the proof on the moivre's theorem. I want to show you the steps involved in proving this theorem. Don't forget to share this video, like and comment. Alright, so we'll be proving this de moivre's theorem using the mathematical induction process. So we want to be proving that this side is equal to this side. So the first thing is when n is equal to 1. When your n is equal to 1, what will you have? You have z raised to power 1 equals what? Open bracket x plus I y raised to power what? 1 equals to what? R raised to power 1 open bracket what? Cos 1 theta close bracket plus I sine open bracket 1 theta close bracket, right, equals to R raised to power what? 1 exponential I theta open bracket 1. Do we get that now? So this will give us z equals to what? X plus I y equals to R open bracket cos theta plus I sine theta close bracket equals what? R exponential I theta. So this is what we are going to have when solving this one, when we solve for when our n equals to 1. Now when n equals to k, when n equals to k, that's the second process. So we'll have z raised to power k. Anywhere we are seeing n now, we are putting what? K. So that will be z raised to power k equals to what? X plus iy raised to power what? K equals to R raised to power what? K open bracket cos k theta plus I sine k theta close bracket equals to R raised to power what? K exponential I theta k. Do we get that now? So this is for when n is equals to 1. Now when n equals to k plus 1, this is where the major work lies. Are we getting what I'm saying? So this is where we want to work majorly. All right, so we'll work with this side first. So we have z raised to power k plus 1 equals to x plus iy raised to power what? K plus 1. Now we want to work on this to get, when we put k plus 1 here, it will become k plus 1, k plus 1. So that is what we want to get, and this is where the major work is, like I said earlier. So we are going to do this using our indices knowledge. So this can also be written as x plus iy open bracket k multiplied by x plus I y raised to power 1, right? So we can see that this is still the same if we apply the indices law that says if I have a plus x, if I have a raised to power k plus 1, it's the same thing as saying a times a again with the other power. Like this is what I use a raised to power what? X plus y is the same thing as a raised to power x times a raised to power what? Y. All right, so this is what I am using. So let's take it further. So don't forget to subscribe, like and share this video. All right, so when n equals to k plus 1 is all you are doing now. So we have x plus iy raised to power what? K multiplied by x plus iy raised to power what? 1. Now you have to know, you can see that when our n is equals to k, we have something like this, right? So when we have x plus iy raised to power k this is what we have. So you are now going to put this here where you have this. So that will be r raised power what k open bracket cos k theta plus I sin what sin k theta close bracket multiply by, you know, when we put our r equals to 1, we have something like this. We have something like cos theta plus I sin theta. This is what we have when we did for our n equals to 1. So our r equals to 1 is multiplying our n equals to what? K. So this is the one and this one that you want to multiply together. All right. So now let's open this bracket. So first multiply this with this one. So that will be r raised power what? K equals to, r raised power k open bracket cos theta times cos theta, cos k theta times cos theta will give us cos theta cos k theta, right? Cos theta times I sin theta will give us what? Cos k theta, then I sin what? Sin theta. Okay, plus I sin theta times cos theta will give us what? I sin k theta plus I sin k theta cos theta plus I sin theta times I sin theta. You know, before I told you before that I times I is what? I square, and I square in complex number means what? Minus 1. So our I square will now make this to become minus. So sin k theta times sin theta will now give us what? Sin theta sin k theta. All right. So do we get that now? So it's becoming a little bit simpler there. All right. So this is r raised power k. Now let's collect like them. So the one that have I will be with the I. The one that doesn't have I will be with I. So we have r raised power k. So r raised power k open bracket cos theta cos k theta minus sin theta sin k theta. So it is this one. I bring this cos k theta and this sin together. So we have plus again, plus I sin what? Sin k theta plus I cos k theta, I cos k theta sin theta plus I sin what? Sin k theta cos theta. Now instead of writing this I can put it outside. I can put the I outside like this. So do we get this now? All right. So as we can see from here, we can see that we now have the real part. You can call this the real part, and this one's the imaginary part. You can see that we are making it into the complex number part, because in complex number we always have the what? The real part and the imaginary part. All right. So now let's continue. All right. Now after this, there is something you can do. Now I want us to remember something in our trigonometric function. If we have cos open bracket a plus b, it is the same thing as saying cos a cos b minus sin a sin b. Are you getting what I'm saying? That means my cos theta cos k theta can also be this. Okay, sorry, that means my cos theta cos theta cos k theta minus sin theta sin k theta can also be equals to what? Cos open bracket theta plus what? K theta. Have you got what I'm doing there? So that means it can also be what? Be cos theta open bracket what? K theta, as I wrote it here. And also recall that sin A plus B is the same thing as cos B sin A plus sin B cos A. Are you getting what I'm saying now? So all these are trigonometric function. All these are trigonometric what? Function. That means I can also see that my cos k theta sin theta plus sin k theta cos theta is the same thing as sin open bracket theta plus k theta. Alright, now as you can see that everything here has now become cos open bracket theta plus k theta, and everything here has become what? Everything here has become what? Sin open bracket theta plus what? K theta. Alright, so instead of me rewriting this, I'll now say r raised power what? K open bracket, r raised power k open bracket. Now cos k theta minus sin k theta has become what? Cos theta open bracket, cos open bracket what? Theta plus what? K theta plus I all this cos k theta sin theta plus sin k theta cos theta has become what? Sin open bracket what? Theta plus what? K theta. Okay, are you getting that now? Now, what's the next thing you do? What is common between this thing? So we have r raised power k open bracket cos, what's common between them? Theta open bracket 1 plus k. You can see that's what will be left, plus I open bracket sin theta 1 plus k. Right? Alright, so after that you can see that we are already making it a little bit coming down. Alright, so we have r raised power k. We want to rewrite it as cos theta open bracket k plus 1 plus I sin theta open bracket k plus 1. And now you can see that this is what I will have normally if I put my r equals to k plus 1 into z equals to r raised power n open bracket cos n theta plus I sin what? Sin n theta that we have before. You can see that when our n is equals to k plus 1, if I put my n equals k plus 1, this is what I will have. You can see, so I've been able to prove this. So what will I do? I'll just need to put, when my z equals to n plus 1, I'll now have r raised power what? N. So anywhere you see k here, you represent it to what? N open bracket cos theta open bracket what? N plus 1 close bracket plus what? I sin theta open bracket n plus 1 close bracket. So you have been able to prove the De Moivre's theorem. I get what I'm saying. So don't forget to subscribe, like and share this video. Thank you very much.